The other way to deploy EKS worker nodes is to use custom launch templates. In this lesson, I will tell you what are custom launch templates, why we need them, and how we can use them to deploy EKS worker nodes. Let's get started. If you didn't follow our social media page, please follow our LinkedIn, Facebook, Twitter, Telegram, as well as our YouTube channel. So what is launch template? Launch template is a service or is some options and a feature in AWS allows you to create pre-configured template for your EC2 instances. By using custom launch templates, you can create a template about EC2 instance, customize everything you need, and when you want to deploy your EC2 instances, you can use the custom launch template. In EKS world, you can use the same thing, and you can deploy your worker nodes using custom launch templates. So you can customize your worker node image, your worker node instance, and deploy EKS worker nodes with some customization. Why we need custom launch templates? Imagine you want to change some security option of your instance. For example, you want to disable IMDS service. I will tell you what is IMDS service and how we can secure it in the next lessons. Or imagine you want to increase the maximum number of pods can be deployed in the same worker node. Or for example, you want to deploy something like bare metal application or something directly to your EC2 instance. In such a scenario, you need to use custom launch templates. The other thing is, what is the difference between using fully managed node groups versus using a managed node group with custom launch templates? When you use fully managed node groups, AWS is completely responsible for creating new versions, creating new custom launch templates on your behalf, and notifying you when a new upgrade is available for your worker nodes. AWS is completely responsible for OS patching and all the things. In addition to managing the life cycle of the cluster, and upgrading worker node with zero downtime. When we use custom launch templates, we have to be aware about creating new version for our OS, patching the OS, and there is no any notification to tell us, okay, the new version and the new AMI image is available for your worker node, and we have to take care of all of them. But AWS take care about zero downtime upgrade, just like fully managed node groups. And the other thing about the launch template is when we want to create a custom launch template, we have to set a custom security group. In the case of custom security group, we have multiple ways. The first way is to use AWS created security group for EKS cluster, and we can use the same security group and set it to the custom launch template when we want to create it. The second way is to create a custom security group for our custom launch template, and then create and authorize and allow the communication between the cluster security group into that security group, and from that security group to itself to be used by our worker nodes. And the third option, which is our best practice, is to create a security group prior to creating the cluster, prior to deploying the cluster, and use that security group for our cluster. And in this scenario, we provide some additional security group to our EKS cluster, and then we use it to authorize and allow access between our resources to EKS cluster or from EKS cluster. The other thing is we have to find the proper AMI image, EKS optimized image, to be used for our worker node. AWS provides some EKS optimized image, which consists of kubelet, containerd, and a couple of other things like bootstrap script to deploy worker nodes. So we have to find the proper version. And after that, we can customize kubelet configuration and change kubelet parameters. And when we use custom launch templates, we need to take care of checking for the new updates, checking for the new image, and upgrading the custom launch template, and then upgrading our worker nodes. Okay, so what is the procedure to create custom launch templates and after that deploy EKS worker nodes using that custom launch template? The first thing I want to mention is the second option. In this lesson, I will explain the second option, that we want to create a custom security group for our launch template for our EC2 instances, and but you can use the other two options and use the best practice, which I mentioned before, to create a security group prior to creating the cluster. So you can customize that security group and allow access between resources to the cluster or from the cluster, from the API server to those resources. After that, when we create the custom security group for our custom launch template, we have to allow the traffic between the cluster security group to that custom security group, to be able to communicate from API server to worker nodes, from worker nodes to API server, and from worker nodes to themselves. And after that, we have to find an EKS optimized AMI image for our worker nodes, and that should be completely matched to our EKS version, or you can use two version prior to our current version about EKS cluster. And after that, when we want to create our custom launch template, to be able and to allow kubelet to be able to join to EKS cluster, we need our cluster information like the certificate authority, the API server address, and something like that. And we have to retrieve those information from our EKS cluster. And the next thing is to find the maximum allowed number of pods per worker node. When you work with EKS and you want to use AWS VPC CNI, you should be aware of the maximum pod can be deployed into the worker node. AWS and all the most of AWS instances have some limitation. And that limitation is because of the number of network interfaces can be attached to the instance, and the number of IP addresses can be assigned to the same network interface. And there is a custom script provided by AWS, you can provide your instance type and get the maximum pods can be run into that worker node if you want to use AWS VPC CNI. But if you want to use something else, some other CNIs, you can, by using the custom launch template, you can customize it. You can tell kubelet, you can use the maximum number of pods, and you can deploy lots of pods into the same node because you want to use some custom CNI like Cilium, Calico, or something like that. And after that, when we have all the information, we have to create our cloud init user data to run bootstrap script to join kubelet to the cluster. And then when we have the user data, when we have the information about what the EC2 instance should do when it's up and running, we can create our custom launch template. We can create the EC2 launch template and then create a node group based on our launch template. And then we can use the cluster with some customized worker nodes. This is the diagram of what should we do inside our AWS account. So we have the cluster, and the cluster is deployed into AWS managed VPC. And when we created this cluster, AWS automatically deployed a security group for that cluster. Now we have to create a new security group in our environment, in our VPC, and allow the communication between that security group to the cluster security group for both sides, from both sides, as well as allowing the communication from our custom security group to itself to be able to allow worker nodes in that security group to communicate with each other. And if we want to get connection and SSH to the worker nodes, we have to allow SSH traffic to that security group. And after that, we have to find EKS optimized image ID, find the proper number of pods, the maximum number of pods can be deployed into that instance type we want to use, and then create our cloud init user data file, and then create a launch template and use that launch template to create node groups. And after that, EKS will create auto-scaling groups by using that launch template, and our worker nodes will be deployed to our cluster. Okay, so let's get started. We have to create our custom security group. The first thing we have to do is to docker exec okay, we have our security group. Let me copy the value here because I need it. The next thing is to allow the communication from this security group to itself, because when we want to deploy our worker nodes should be able to communicate with each other. So we have to run this command. Okay, the next thing is to allow traffic from control plane to all the resources using this security group. Now we can go to our VPC and find the security group of that cluster. This is the security group of the cluster. Is get created automatically by AWS. Let me copy it here, and now we have to use this one to allow communication from control plane into this security group. And of course, we need to do the reverse thing. So we need to allow the communication from the cluster to worker node and from worker nodes to cluster. These security groups allow the communication from our control plane to worker nodes, and the other one, this one, allows communication from worker nodes into the cluster. Okay, let's execute this command and execute this command. All set. Now if we go to this one, you can see we have it, and if we check the cluster security group, you can see the communication is allowed. The next thing we have to do is to allow SSH connection. We can execute this command and allow SSH into that security group. The other thing is to find EKS optimized image. Inside that image, AWS provides all the things we need to create an EKS worker node. Some things like kubelet, containerd, the bootstrap script to run kubelet on our behalf and send the parameters and all the things are available in that EKS optimized image. And with using this command, we can get the latest available version of EKS optimized image. And you can see we can provide the version of our Kubernetes cluster. We can provide the Linux distro. And in our case, we want to use Kubernetes 1.28 with Amazon Linux version 2. So if I execute this command, it provides me the latest version of EKS optimized image with kubelet version 1.28 based on Amazon Linux version 2. I need to copy this one here. And after that, we have to run a couple of commands to get the cluster information. The first thing is our cluster endpoint. This is our API server address. The other command is to get the certificate authority. This is the cluster certificate authority. We have to copy it here. and we need the service CIDR block to calculate core DNS IP address. After that, we have to find the maximum path can be run on EC2 instance. We have to install JQ and curl inside our Docker container in our workstation. We have to download max path calculator script. Allow to execute it. We have to make it executable. And now, by using this command, we can provide instance type as well as our CNI version. And it shows us the maximum number of pods can be deployed into this worker node if we use AWS VPC CNI. So we need this number as well. I'll copy it here. Now we have to create our user data file, the cloud init user data file. This is our template. You can use this template and change the information here. We need the API server, so I can replace this value. We need the cluster certificate authority information. We have to replace it here. And we need the cluster core DNS and DNS IP address. It's good to know. It's normally in Kubernetes environments, when you have your CIDR block, in that CIDR block, in the first block, the 10th IP address is assigned to core DNS into kubedns service. So we can use that IP address. And if you check here, the number of maximum pods can be deployed into that worker node is 17. So if you use something else, if you use something other EC2 instance type, for example, instead of using T3 medium, if you use something else, and by running this command, you can find that the number is different. And now we have the cluster API address, the cluster certificate authority information, cluster DNS IP address, and the number of maximum pods. We have to create the user data. This is our file. The user data is available now. And now we have to create our EC2 launch template. Let me copy this template here. And in this template, we have to provide image ID that we fetched before. This is the same. We have to provide this information, the instance type, and we have to get the user data content. To get the user data content, we can use our user data. As you can see, data encoded to base 64. And we can copy that here. And in security group ID, we have to provide our security group ID. This is our security group ID. And to be able to connect to worker node using SSH protocol, we can provide our key pair name, and that's it. So we have to create the JSON file for launch template. This is the launch template JSON file. And now we have to create our custom launch template. Custom launch template is ready. If we go to EC2 service and check launch templates, you can see the launch template is available here. If we check the advanced details, you can see we have our custom user data. And now it's time to create EKS node group with using that launch template. It's the same thing like what I mentioned in previous session, and we have to do the same thing, but in this command, in addition to providing all the information like before, we have to provide the name of our launch template. This is our custom launch template name, and we provide the version, and all the other things are same as what we used in previous lesson. Okay, it's done. Is it our node group for critical add-ons? We can create another node group for our normal applications. Application node group to deploy our workloads. And now we can run the wait command to wait till our node group get activated. Now if we check our EKS and check our compute, you can see our node group is creating, and in the launch template tab, you can see it used Kubernetes EKS custom launch template. Okay, it's done. It needs some time to be deployed. And in the meantime, I want to mention something that is related to EKS. If we get back to our EC2 and go to launch templates, you can see something happened. And what happened here, when you provide your custom launch template to EKS service, EKS automatically duplicate that custom launch template for each node group you want to deploy. So as you can see, we have two duplicated custom launch template for our both node groups deployed to the EKS cluster. And when we want to upgrade our launch template, we have to change and upgrade this launch template, the launch template created by us, and AWS automatically create the other ones for deploying and upgrading worker nodes. Okay, this is what I want to mention. Let's see if worker nodes is available. Yes, they are available. Now, if we go to our system and check AWS EKS update kubeconfig with the name of cluster, kubedemi cluster, and check nodes, you can see our worker node is ready and we can deploy our application and workloads.